Okay, welcome to this session's Lunch and Learn. I'm going to be covering both how to start a Phoenix project and the configuration changes that I found through analysis that will help us more secure it better than the default new app would be, which we care about for our use case. As you all know here, but for anyone watching the recording later in the company, I'm a senior software engineer on the Masterpoint architecture team, and one of our prototypes is looking into the Phoenix framework for use for WebSockets because there's not a great story right there in Ruby and Rails for us. In my free time, I work on the IntelliJ Elixir plugin for IntelliJ IDEs, which would also be useful for us because we all like RubyMine. As an outline, I'm going to go over installing the tools, which will be helpful for all the team that hasn't started looking at this yet. A new project, the configuration, how to set up a TLS, how to set up a simple authentication, how CSRF protections work, how channels work, what to do about cross-site scripting, and how to recover from compromise. Installation has two parts, the dependencies from Node and the dependencies from Mix. To get Node, for most of us, we can brew install Node to just get it from Homebrew. Node is required for Brunch.io, which is used for ACID compilation. It is optional, but I'm using it because it's the easiest setup when starting a new Phoenix project. And this assumes that Erlang and Elixir is already installed, but you can also do that with brew install Elixir. Mix local hex ensures your version of the hex package manager is up to date. The archive.install pulls down the phoenix.new task from GitHub. As you can see from the URL, this presentation was written against 0.17.0, which was the last version before 1.0, which was released 1 week ago, so there might be a couple changes since then. For a new project, I'll cover how we could set up other options for phoenix.new, how a normal phoenix.new works, and going through the dependencies and actually starting up. So we have a couple options to control. Normally you don't need to specify any of these options, but they are just derived from the directory name. But if you want to use different naming scheme or nested namespaces, you'll need to manually override app and module. By default, phoenix.new will use ecto with Postgres. Ecto is the, not really the ORM because it's not an object mapper, but sort of like the active record equivalent. If you prefer a different database, you can override that with -- database. If you don't need a database at all, you can disable ecto with -- no-ecto. Even if you need a database, you can still create the project without ecto if you want to use. Erlang has a built-in database called Amnesia, and it also has DETs, which is on-disk ETS tables, and they're very efficient for concurrent reads and single write. Or if we want to use a NoSQL alternative like React, which is nice because it has very good eventual concurrency stuff with CRDTs. You could use -- no branch if you want to use the branch, such as Webpack, to compile your assets, and there are blogs online about how to do that if you decide to go that way. If you don't have HTML or assets because you're just building a JSON app or a channel server, you can also use no branch. This is the output from Mix Phoenix New. With only a path, it'll create config files for dev, hot, and test environments, and those are their actual names. It's not me just saying it in a short way. It's really called dev, it's really called prod, it's really called test. A single endpoint for this project used for errors and layout. XUnit-based tests that the one test in there is actually checks that your server is up to date because the Phoenix server is so lightweight that they can actually have it running, but not externally during the test to prove that your connection requests actually work. So we can actually test that SSL works during the test. It's not like handwave is a direct function call. A default page controller, templates for layout and page, the routes, the ecto repo, and the default assets. Mix Phoenix.new is interactive, so after creating the new files from the last slide, the Mix task will ask to install dependencies. Saying yes will install JavaScript dependencies with npm install and Elixir dependencies with mix-deps.git. You should take note that this only happens when you do Mix Phoenix New. If you guys pull down repo by cloning from GitHub, you're going to have to remember to npm install and mix-deps.git. But if you forget to do it, there are red error messages when you try to start the actual server, and it'll tell you, hey, you forgot to run mix depskit or npm install. The error message isn't just a cryptic error message. It says what command to do to fix your problem, which is really nice. That's actually a general philosophy of the Elixir ecosystem that Jose Balloon, the language creator, did, that like bad errors are bugs, and if an error doesn't even happen and it's a silent bug, that's worse. So at the very end of mix Phoenix new output, it tells you instructions of how to actually run the app. So we'll cd into the directory, but before we do acto create, we're going to secure the database and other parts of the configuration a little bit. Phoenix projects have two secrets, the secret key base and the database password, similar to Rails projects. The secret key base is used by Plug for session encryption and signing, and by Phoenix for channel tokens. If the secret key base is disclosed, it's possible to either read session cookies or fake cookies by signing session. Cookies contain your own data. The database password is, of course, used to log into the database. The database password is disclosed, then all your data is accessible. By default, the prod secrets are kept in a separate prod.secret.exs that is get ignored, not keeping production secrets, and source control is best practice. But by default, Phoenix does not keep your development and test secret, does keep your development and test secrets in source control. I see two problems with this. First, it means your entire team uses the same secrets. And second, if your repository is public, I can see your secrets on GitHub. And this exact thing has actually come up when people just recently accidentally pushed an AWS key to GitHub and Bitcoin miners took over their account. So there are people actively scanning GitHub besides us for secrets. So we have to be very careful about protecting this stuff. You may think these aren't issues because they are not meant for production, but if you end up replicating part of your data development, which isn't a problem for us with Metasploit, but could potentially be the case for like a user site, I suppose, and someone gets access to the network, you can end up divulging production data to the attacker. Additionally, if you reused or weak passwords, an attacker can use your dev and test passwords to more easily guess production passwords. The first step to securing the configuration is to remove the shared secret key base from config/config.exs, which will force each environment to supply their own secret key base. The secrets for all the configurations should be kept out of source control, so we'll remove the import config prod.secret.exs from config/prod.exs and add an import that uses mix.env to import an environment-specific secret into the configuration file. So this is important to point out that unlike Rails, the configuration files for Mix are full Elixir code. There's no separate step of like ERB and then YAML. It's all Elixir. So you can use variables so that you can be intentionally revealing that like this is the port difference between the two, or like this value is meant to be repeated, and so I'm going to put in a variable so you know they're supposed to be the same on purpose, which is very helpful. I would think it's not just a problem with us. It would be the same thing with, like, this secret key base system is also used in Rails, so I would think so, because each side has to be able to decrypt the cookie. So I would think yes. So to regenerate the secrets, we can just go into IEX, which is the equivalent of IRB, and use the crypto library, which is the OpenSSL bindings built into Erlang to get strong random bytes, which is the equivalent of secure random in Ruby, or getting bytes out of dev/random as opposed to urandom, which gives up if it doesn't have enough entropy. This is the same code that Phoenix.new ran for us, but we're going to rerun it to get new secrets for each individual dev. The advice for strong passwords applies even more for prod than for dev or test. In addition to replacing your password every 9 days, or in general have a key rotation cycle, you should do the same for your secret key bases. This will validate any active sessions that your user has, but this is also a good thing because your users should be replacing their password every 90 days. Here I'm using KeybAssX to generate a strong password and store it, so I have it on file if I accidentally delete my secret configuration files or clone to a new directory. The config/dev.secret.exs will have the secret key base for the endpoint and the entire repo configuration. You could put the common keys for the repo configuration in config/config.exs, but this way the reader doesn't need to know which keys are at fault. So the config macro call here layers the keys using a key merging algorithm like you'd think hashes would be merged, because the keyword list acts like this multi-value hashes. So it would merge, but you'd have to think in your head what was the default from the other file, and this way you can just see them all at once, so it's kind of easier to keep track. Notice that I'm using a separate username that matches the database name. This way users can have minimum permissions to only interact with its own database. The secrets for tests look the same as for dev, except removal of the size option, and there's a special sandbox pool used just for tests that you can see on the second to last line. So pool active.adapters.sql.sandbox. And that's from the default config. If you do need to create new users for Postgres and you've done before, you can either use create user from the command line or use pgadmin 3 if you want a GUI interface. The GUI interface has the benefit of you can double check your work before committing it. And so I like it for that fact. Now with the secrets outside of source control, we can create the database using the command mixphoenix.new gave us. You may wonder what's going on when you run the command, because you'll see a bunch of like fs compile and a bunch of compile messages. Why this happens is because the first time you run a command in the project, it needs to have the compile time dependencies built. And so it's going to compile those dependencies first and then run the command. If you had previously compiled your dependencies directly with mix-steps.compile, mix-ecto-create would just show you the thing in the bottom where it just says the database for the repo has been created. Now we'll cover securing with TLS. HTTPS should no longer use SSL. When speaking about encryption for HTTPS, you should say TLS now, because it was defined in 1999, and all the SSL versions are actually considered insecure. You shouldn't use them. Phoenix through Plug has built-in support for TLS without the need for a reverse proxy like Nginx. We want to use TLS because we will be authenticating users. So if we don't use TLS, the user's password and cookies will send plain text on the network, allowing attackers to steal them and impersonate the users, a la the Firesheep extension that got really popular when Facebook used to not use HTTPS. To start making phone, we are developing HTTPS to have any HTTP assets leaking through. We're going to generate a private key from the certificate authority. We're going to use our password manager to generate a long password for this private key. We'll choose 4096 bits just to be extra careful. The current recommendation is 2048. Non-self-signed certificates usually last from 1 to 3 years, so I'm using 365 days. When I generate the certificate, I'll get an interactive prompt. Some of these options do have command line options, but unfortunately some of them only work from config files, so it's probably just easier to get the interactive prompt than to set up the config file with the distinguished name fields. Distinguished name is a certificate standard, so it has country name, state or province name, locality, organization name, organizational unit, and common name. For the certificate, the common name can be anything you want, and so I just make sure that everyone knows it's a self-signed certificate from me. And if you ever want to look at an OpenSSL cert, you can use the X509 command, and it'll actually spit out what that weird binary blob actually means. And this can be a good way to check that your command line options actually turn on the flags you thought they did. We'll generate a separate server key for each mix environment so that the server certificate only works for the domain for each mix environment. And we'll be alerted if we start using development or test URL with the wrong server. Or if there was a staging service, would be even more important. Since the server certificate is not self-signed, signing is broken into two parts. The request for the server's key to be signed and the certificate authority actually doing the signing. This two-part process makes sense when you think of how real certificate authorities like VeriSign have to sign your private key, but you don't want to send it to them over the internet. So they sign the request to be signed, not your private key itself. So your private key remains private. It's not like you're sharing it with the root authorities. I use the same country, state, locality, organization, email address as with the self-signed authority, but the common name for the server must match the address I'll use, or you're going to get a cert warning that the name is invalid. And then you'll have that pop up, it'll be red, and no one should trust your shit. To make it easier, I'm just going to assume that the mix environment is the start of the address, so dev, and then I'm going to name it after the project, running securely with Phoenix framework.localhost. To sign the cert, we have to pass in the certificate authority. The CA create serial is because certificates signed by a CA must have a unique serial number. And so the CA create serial just dumps the file to disk and starts the count at 1. So if you want to reuse this cert, you'll just keep it tracked. But if you move around where you're creating the cert, you have to be aware where that file is so you don't issue 2 certificates with the same serial number on your network, or bad things might happen. We need to use the CA's key because this is a signing event, so we need the private key to actually do the signing. And then we say how long it's good for, and I'm just picking 90 days so it follows the normal key rotation I recommended. To actually trust the cert for our development environments in OS X, you have to open keychain access, click the plus sign to add the certificate authority cert, highlight it, click I on the bottom, and then you're going to get a dialog that has the collapse arrows. You're going to uncollapse trust and then change to, when using this certificate, always trust. And then we're going to close the dialog and it'll prompt to you for your password like keychain always does for any actual change. And that way you won't get an untrusted cert warning in Chrome anymore. So you'll be able to test that your certs are working as expected in production. So since we're using fully qualified domain names, we need to be able to reach them. I'm just using Etsy host instead of DNS to do this. And for Chrome, you can either start a new tab to refresh the cache because it has to be in a separate Chrome process, or you need to potentially restart your browser depending on how your browser works. For the TLS configuration, we need to disable the default HTTP strict transport security because it doesn't work with HTTPS ports other than 443. The standard, the RFC for HSTS actually says that if you're on port 80, we'll change you to 443, or if you say nothing, we'll just assume those ports. But if you're on a different port, it doesn't let you specify the port for the redirect. So if we're using an internal app that's on weird ports, we can't use HSTS. But we should use it in production, of course, because it's best practice. We set the OTP app setting at the bottom because that allows us to use relative paths to all our TLS documents, and we just put them in the prib directory because that's the standard layout for Erlang projects. Is anything that you don't want to serve or that isn't supposed to be used by code calling you is in a prib directory. For a redirect from HTTP to HTTPS to work, the force SSL setting needs to know the HTTPS port, which means that that sign is repeated here and for the HTTPS port. So like I said, this is for Elixir. I can actually use variables to repeat my values, and I even go through the trouble of saying, well, the normal prod port is 80 and the normal HTTPS port is 443. So if in dev I'd usually been 4000, what is the same gap between the ports to put HTTPS in dev on that so that I have a pattern of my ports for each the gap calculation, since it does use 80 and 443, and test follows the same pattern as dev with the gap calculation. With the certificate already trusted in the Phoenix server over TLS, we have a green padlock. To actually start the server, you do mix phoenix.server, and it'll issue Cowboy, which is the underlying Erlang server that Phoenix is built on top of. Will show you 2 URLs, HTTPS URL and HTTP URL. So we want to hit the HTTP URL and make sure it redirects us to the HTTPS URL, which it does. And it's a green lock because I made sure you SSH 256 and 496 bits, because right now Chrome will warn with a yellow padlock and a warning symbol if your cert uses SSH1, which unfortunately some banks are. So now that we have the connection secured, we can feel confident about passing passwords and cookies for authentication, so we'll implement that. If you are making an application on the internet, please consider not having your users create a new account and password for your site. Then your site just becomes another site that can have a password breach. Instead, let password security be someone else's problem. Use OAuth to allow sign-in from social networks, or use SAML with Okta and allow users to log in with their private company Active Directory credentials. If none of these options work for you, or you want to fall back in case the users don't have accounts at other providers, then you can implement passwords in your application. The code for this section is based on Michael Etherly's Phoenix app with authentication from May 11, 2015. It's been updated for changes in newer versions of Phoenix and some stylistic changes. Phoenix has generators for create models. It takes user, which is the module name, users, which is the table name, and then a list of field names. The field names can have colons after them to say the type. By default, they'll go to string, which is the same way that Rails generators work now. We create a bare minimum user with a unique name and hash passwords. Note that I called the field password hash because it's a hash password. It's not encrypted. A lot of example code confuses encrypted passwords, which can be unencrypted and recovered, with hash passwords, which can't be recovered. Hash is one way. Hash passwords are only cracked by finding the input string that happens to make the same hash as the hash on file. If you ever have a choice between encrypting or hashing passwords, choose hashing passwords, and just have users reset their password instead of having unencryptable passwords that you can send back to the user if they forget their password. Plus, you then run into the whole problem that you just send their password plain text an email, and it probably wasn't secure anyway. If you can unencrypt a password, that means that an attacker that gets access to your unencryption key can also read all your users' passwords. Schema is a macro for Ecto that defines the type of each field in the Ecto model. The fields aren't automatically inferred from the database because, one, Elixir in general believes in more explicitness, and two, an Ecto model is more separate from the database. It allows for form-only virtual fields like password and password confirmation, as seen here. In theory, you can have two Ecto models that point to the same database table, and only they have different real and virtual fields exposed from the database columns. Ecto separates the model, which is a simple struct, from data about whether the params the user passes are valid and what changes need to be persisted to the database in an ecto.changeset. Cast does three things. One, it errors out if the required field is missing params. Two, it only allows required and optional fields to be copied in the chain set. So this prevents an attack where the user is trying to send so many params that you're going to have a memory explosion. And three, it converts the allowed params to the type given in the schema. And that's why it gets the name cast. Validations are applied to the chain set, and errors are recorded in the return chain set, so they are just functions and not DSL. This gets around the whole problem of validations in Rails being a DSL, where you then end up having to have if and unless, and you have code inside of strings to disable or enable validations. Because they're just functions, you can just have different chain set functions that run different validations. You could even use pattern matching so that instead of the first argument being model, you could add another argument that was like, oh, an admin. So these are the allowed validations when you're an admin and the ones when you're a user, so that you could say that the user can't make admins. And you wouldn't need ifs on your validations anymore. You just call a different function to do that. These validations are even chainable, so you don't have to pass a model as the first thing to a chain set. You can also pass another chain set. So you can have a set of validations in another function that's just applied to users and not applied to admins. So there's you have less duplicated code that way. Instead of validating for uniqueness with a select in the database, like active record would with validate uniqueness, unique constraint annotates the chain set so that if a unique index error from the database is thrown, it is transformed into a validation error. This is more efficient than validating the uniqueness with select when the call happens because it eliminates a trip to the database and isn't prone to the race condition of doing a select first and then trying to do the insert. As a general rule, one should never write in encryption or password hashing, so I'm taking the advice and using come on in to use bcrypt, which is a known hashing algorithm to salt each password and hash it for me. Salting adds a randomly generated string to the user's password before hashing, which does two things. If two users have the same password, it stops them from having the same password hash. This can be an issue if there's a breach, and the breach also includes password hints, and one person's password hint is either their password or it's really obvious what it is. And then you automatically know, if they're not salted, that that other user must have the same password. And that way you can chain known passwords together to breach more accounts. Two, it makes passwords harder to crack in bulk because an attacker needs to start over for each salt in the database, and they can't use rainbow tables as efficiently. For this presentation, we'll limit the user controller to just registering new users. In a real one, of course, you'd have delete and allow them to update their information, that sort of thing. We'll use scrub params plug to convert empty strings to nils, so there's no need to have a blank function that treats empty strings as nil the same. We can pre-process the params to just get rid of those, and they have to come through as nils, which pushes it up to the level of the controller, which is nice, because the controller is the thing that's supposed to be interacting with the web. Your model shouldn't have to care about that. The new action renders a change set for the form. A change set is used instead of a user struct because change sets can hold things like validation errors and previous inputs. So this way, an empty new form and a new form for a failed create can use the same form, which we're used to from Rails. Using is all that's required for a registration view because we use the standard naming convention for our HTML templates. So this is EX, which is like ERB. The gray lines are the embedded Elixir. Less than percent is run this code. Less than percent equal is take the output of this code and put it into the HTML. We use form for a function with the passed in change set. Passed in variables are called assigns and accessible with the at macro. They are not the same as module attributes, which also use the at symbol, but can be thought of similarly because they're treated as constants for the purpose of the template. Pay special attention that the percent equals from the EX tags must be used for anything that outputs HTML code. This includes non-obvious like macros like if and for, because our for loop is as HTML inside of it. And so the output of the for loop would be all those LIs. So we need to use an equals there. So this makes it much more general because in other template language, they actually have the special case if to be like, oh, grab the thing inside you. And this way it's just, it is the value of the expression, so it's much simpler. So there's a bunch of CSS classes. Those are all from Bootstrap, which Phoenix uses by default. When the new form is submitted, it goes to the create action in the registration controller. Same thing we're used to in all our Rust controllers. If the change set is valid because the name is present and the password and password confirmation match and are long enough, then use them to generate a password hash and insert the user into the repo using repo.insert. But the insert can fail if unique constraint is violated. So we check for errors from the insert in the case macro. So this is like almost 2 levels of validation because remember we're using a unique constraint, so we only have to check the uniqueness constraint by the database checking it. So we have to check that our insert worked even after we check that the change set was valid. The current user ID is stored in the session instead of the current user so that a stale user format can't be retrieved from the session. It also keeps the session cookie size down, and it also so like the whole user, because it's a struct, it's really a map in Erlang, and everything in Erlang is serializable because they have such simple data types, and they're actually meant to talk over the network distributed nodes. So you could put anything you want in the cookie. So you want to be very careful about what you put in the session so that you don't end up putting big blobs of code in there. Once logged in, we need what? You can send functions over the wire. So yeah, of course you could, because you can actually grab code from another node, because that's how you can access like tab completion. So yeah, compiled code is shareable across the network. Yeah. Yeah.
We're not talking about PHP.
So once logged in, we need a landing page. So we'll move the page controller, which is by slash by default from the generator, and move to slash pages, just so we have somewhere to go. We only want logged in users to see the page. We'll use a plug to check that users are authenticated. A plug is, well, everything in Phoenix is actually, there's just sugar on top. So a controller is a plug. But a lot of people would probably use it thinking of plugs as either rack middleware or before filters. But plugs are everything in Phoenix. Plug is actually a lower level library that Phoenix is built on top of.
Kind of like
They're simpler than that, and I'll get to that in the next slide. So plugs can either be individual functions or modules. Modules have the benefit of allowing options to be passed. So the interface for module plugs are they have init and they take one argument, and they have call and they take plug connection structure and the options that were passed to init. So init can be there if they want to modify the options or change behavior based on that. Yes, def p is private define. Here we're not using ops, so they just passed unused through init/2 to maintain the signature and prefix, and the prefix with underscore ops to let the compiler know that we don't expect to use the variable in calls. When you do compile Elixir code, there will be compile warnings that you're, but they're not color highlighted, so you have to just be looking for it. The bulk of the plug is to assign the current user function, where each clause does a single transformation to convert a connection to a user ID and to a user. The final clause handles both if the user ID is nil or if the user is nil. So the path through, we will always have a connection, but we might not have the ID. So the first, the second line, on ID, would match when the ID was set. But if it's not set and it must be nil, then we're going to go to the last clause and redirect to sign it. And then that one will then try to look up the user, but that could also be nil. So the last clause with the don't care on the argument works for both the ID being nil and the user being nil. So we only have to handle that case once by using pattern matching. The plug.halt is important as it stops the pipeline of plugs. So instead of throwing exceptions to stop the processing like we would have to do in Rails, you can just tell the connection that you want to halt processing. And the way plug works is it's like the pipe operator in Elixir, where I'm going to go into the next function call, but after each step, it's like, is the connection halted? So it's doing that for you so that instead of having to have a chain of like, did an error happen? It didn't happen success or failure, which you'd have to do with a callback chain in like JavaScript. This way it's more like monads, where you only have to handle the cases you care about and you can ignore the other ones.
And that call gets garbage collected automatically.
Yeah, when the process dies, it's garbage collected. And each connection is a process. So once this request happens and it disconnects, it goes away. And because it's a single request garbage collect, it's a much faster garbage collection. Registered users are automatically signed in, but users need a way to log in and log out. So we'll add routes for that. There's no unprotected page besides registration, so we'll repurpose / to be the login form page. Like the registration controller, we're going to use scrub params to convert empty strings to nil. Like this is almost like an idiom. You're probably always going to want to scrub params. The new code uses change set just like the registration controller is new to allow form errors. Once again, we're going to use HTML, so session view just uses the use macro to pull in the defaults. But if we were doing JSON views, you don't actually have to go all the way down to the template level to do JSON. You can just make maps here and it'll be rendered as JSON. So you can actually match on what would look like a string of a template name. You can just pattern match here and pretend your JSON template is just a map here in this module. It's pretty much the same form as for registration, just without the password confirmation. When the new form is submitted, create will attempt to log in the user. Create only looks up the user if the name is set, saving a trip to the database. If the retrieved user or nil is then passed to the sign-in form, which just like the if has a value, so that's being typed into the sign-in as the first argument. To show an error if the user is nil, which handles both the username being nil and the user not being found in the database. If the user is found in the database, when common-ins bcrypt support is used to check the password against the stored password hash. If the password is correct, then the user is signed in and redirected to the landing page. If the password is incorrect, an error is shown by redirecting the new form. Take note of the sign-in error module attribute at sign-in error. Make sure that the same error, whether the name or the password is incorrect. I don't want to disclose if the name is correct, but the password is wrong, as that allows for user enumeration, which can help with other attacks. So for this demo app, though, because it has open registration, it doesn't really matter. But for our actual use case, making sure our error messages don't disclose users is an important feature. The current user will only be assigned if the user is logged in. So we use access lookup, square brackets, on con assigns instead of using @current user to check if it's nil. So Phoenix, if you use an assign that's not assigned, it'll error out so that you don't have silent bugs where you get a nil value when you're not really supposed to. So you have to explicitly say, yeah, I know this might not be here, and we're writing the code that way on purpose. There's no doing an at variable in a template, and oh, I get nil, and it just silently trickles through the entire system. Yeah. If the user clicks the log out button, we delete the session and redirect back to the log instance. All pages are protected. So we didn't cover CSRF when we went through forms. So we're going to jump back to that now. CSRF stands for cross-site request forgery. It happens when one site is able to force a user to execute actions on another site because browsers automatically send cookies to their respective sites. Having a secret cookie doesn't matter. So like a cookie where we randomize the name, or a cookie where we don't tell people about it, or it's kind of cryptic, or it only happens once a user is logged in enough, doesn't work because anyone that uses that can use it, and it's not that secure. Only allowing delete, patch, post, or put requests and not git would prevent links triggering CSRF, but a malicious site can easily construct post requests using hidden form fields or JavaScript. Having a complex set of steps to complete a transaction, such as many pages and forms filled in a bank transfer, doesn't protect if the attacker can figure out the correct sequence, and unless your app is super fucking confusing and users themselves can't figure it out, the attacker is a user first, and so they're going to be able to figure it out. Rewriting URLs would involve putting the user's session ID in the URL, which means that anything that saves URLs, such as history or people that share bookmarks, would have the user session in it. And this user session ID in the URL was actually kind of popular like 10 years ago in some frameworks. This is kind of scary. It is your responsibility as a developer to not have GET requests change state. In addition to malicious attackers, spiders for most search engines will follow GET links, but not for other requests. So if you have a GET link that changes state, then your search engine spider can blindly start altering your application state. Right now, the application isn't vulnerable to cross-site scripting because no input from one user is viewable by another user, but we'll cover cross-site scripting protection after we get to the chat. Using a unique token for each form is the current standard for protecting forms in web frameworks, including Django, Ruby on Rails, and Phoenix. We've actually already enabled cross-site request forgery protection in our forms by using the form for function, which adds a hidden input for underscore CSRF underscore token. So the actual rendered HTML you can see on the bottom, which is the same thing that happens for Rails. Yeah. Yeah, there are lower level like tag making functions that would bypass that, and you'd have to remember to do it. But if you use form for, just like if you use the form helper in Rails, we'll be safe. The CSRF token is verified by comparing the token submitted in the request with the token stored in the session. The CSRF token in the session can be trusted even when storing a cookie, as is the default, because the cookie is signed and encrypted so the user cannot tamper with it. Each GET request for a form include a new CSRF token and modifies as a session cookie so it has the same CSRF token in it. The reason an attacker cannot read the form to recover the CSRF token to resubmit with an updated cookie is due to the same origin policy. Web browsers ensure that requests from one page to another are only allowed if the protocol, host, and port match. Some older browsers sometimes didn't include the port, though, so it's something to be aware of if you're using older browsers or have to support them. This prevents resources from the HTTP version of a site accessing the secure HTTPS version of a site, Google.com accessing your bank site, and two internal apps running on different ports on your company's intranet from accessing each other. Without same origin, CSRF couldn't be prevented with storing the token in both a resource on the form and the cookie because the attacker could read the form, fill it in with the hidden CSRF token, and the browser would send along the cookies on the attacker's behalf because you accessed that site that gave those cookies originally. So now we're going to set up chat using Phoenix channels. Channels are one of the cooler features of Phoenix where the concurrency support of the Beam really shines. Beam is the VM that Erlang and Elixir run on. Instead of a standard request-response cycle, channels allow bidirectional communication over WebSockets, and they also have support for long polling, allowing messages to be pushed from the server to the client and between clients through the servers. And always used for this is soft real-time chat. And as mentioned, this isn't just a web technology, there are already clients for Android and iOS, and I think both in Objective-C and Swift. Yeah, the channel isn't a WebSocket. The socket is below that level. To the bottom of the web/template/page/index.html, we'll add a div for chat messages and input box where the users can type messages. To make registering for events and updating the form, I'm going to use jQuery because I'm out of date with JavaScript, and jQuery is what I use. I don't know if that's good anymore. I need to add it to package.json for Node to install, and I need to tell Babel, the ES6, ES5 transpiler, to ignore jQuery because jQuery is already ES5. If you don't do this, when you compile your assets, Babel will complain that it can't find the module definition because it thinks jQuery should be ES6, which should have module definitions. Mixphoenix.new generates a socket.js that is disabled by default. We'll now fill it in our chat. We'll get a socket token from a meta tag because channels aren't tied to HTTPS-based tokens, so we can't depend on the headers being sent, and cookies are headers. Rooms::lobby is an example channel from mixphoenix.new, so we'll just reuse it for this demo. The chat interface waits for the server to press enter, which sends the message to the server. The server then broadcasts the message to all users, including the one who originally sent it, and they add the message to their chat log. The backtick string down there those are interpolated strings in ES6. So JavaScript 6 has interpolated strings now, but because of backwards compatibility reasons, they had to use backticks instead of quotes to make sure that it errored out correctly, I guess. So to make socket.js work, we need to make socket_token available in the meta tag, which we do by adding it to the layout. This has to be protected if the user isn't logged in, since the layout is used on the login registration page. To generate the actual token, we use phoenix.token.sign, passing the user as the salt, which must be known on the sending and receiving side, and both the user ID and the user socket token, which hasn't been defined yet in the user model. The socket token is used along with the ID so that the socket token can be changed if the user account is compromised, and it will invalidate the signed tokens embedded in any open pages. If you just use the user ID, then there's no way to invalidate the signed token besides having the token expire, as the sign function embeds the signing time. But you'd have to somehow make the expiration time for all users get up to that time, or somehow be able to make a single user's token be, yeah, this token actually expired now and not in 2 weeks, which is the normal time. So it's much easier to have a field you can control from the database. The migration has to do the dance of making a null column, populating it, and then making it not null to handle any pre-existing user accounts. To populate the field, we want strong random bytes, so we'll use the gen random bytes from the PG crypto extension. To use create extension, though, we need to up the user's privileges to super user. So you either have that option of making the database user a super user, so it can use create extension to efficiently generate random bytes in Postgres, or if you want to keep the user not a super user and only have create database permissions, you would have to load the data into memory and then do single row updates so that each user gets their own secret.
Why are you using Postgres to do the generation of the bytes instead of the library we use for generating?
Under the assumption that on like a production app, you might have a large number of users, and so it's more efficient to have the database run it for you. But yes, that is the other approach of doing it in memory. To be able to access the field from Ecto, we need to add the socket token as a field in the user schema. We already had to generate the password hash when we create users, and now we'll generate the socket token. So I changed the call after the valid to be user.foldChainSet, which will generate both the password and the secret token. So user full chain set uses a helper called generate secret that just encapsulates the code that we used previously in IX. This code is actually in one of the mixed tasks, but unfortunately there they also make it a def key, so I can't just call it, which is unfortunate. And then we're going to just generate a secret and put it into the chain set. I'm having the token expire every 2 weeks just to demonstrate. I do that because the Phoenix guide uses an example, and As far as I could find, Erlang and Elixir don't have a time module with the time conversion stuff hardwired, mostly because they're very sensitive about time, and these translations aren't actually correct in a lot of time zones. You know, there's like leap seconds, stuff like that. So, but I don't really care that it's exactly 2 weeks. I just care it's around 2 weeks, so I'm going to do it this way. Phoenix.token.verify only verifies the token is signed correctly and not expired, but that's not enough. Not enough if the user account has been compromised and the credential has been changed since then. To verify the token represents the user's current credentials, we use reader.getBang, which will raise an exception similar to the Rails convention, except much better enforced. And kill the socket attempt if the ID and socket token both don't match. We can safely raise an exception here because, like all connections, this is a separate process, so the process will just die and get cleaned up. We store the user ID instead of the user struct for the same reasons we don't store it in the session cookie, because we don't want to have a stale user structure that might have like old fields like their name if they change it later on. To allow us to kick all sockets from a user such that if a user becomes compromised or just needs the ban hammer brought down on them, we can assign an ID which functions as a back channel name for that socket. So these are sort of like the hidden channels that WoW mods use, like how the auction house talks to each other, or the quest stuff can talk to each other on hidden channels. I let anyone that's got a socket join the lobby, but the payload, the second argument, can also contain an authentication token, so we can have private rooms if we wanted to. handlein/3 looks up the user from the user ID and then calls handlein/4 to actually broadcast the message. And one thing I would say is, because the user could pass in params we don't actually care about and we don't want them propagating, it's important that I deconstructed the hash here and only grabbed the body, and I didn't just say, if I said params equals that body, the pattern actually says it's a map with at least those arguments in it, not only those arguments. So I don't want to assign that to a variable and send it on to the users, because then they could pass in extra fields. So I always want to deconstruct and make sure I'm only taking the fields that I want. There's also map.only, which will allow you to programmatically say I only want these keys to pass through. And that's part of the Elixir standard library. So I have two accounts logged in, Chronic Death on the left and Chuck on the right. Chuck decides to test the security by posting a script tag. Ooh. And Chuck just posted a message using Chronic Death token. Chuck is a dick. Okay, so that gets us to cross-site scripting. So our channel implementation is vulnerable to cross-site scripting, and our user's socket token has been compromised, so we need a way to protect from further attacks and restore the user's account. There are two general categories of cross-site scripting attacks, persistent and non-persistent. The attack launched in the demo is non-persistent only because the server doesn't currently record the chat messages. If we were doing this as a log channel and we stored it in the database, then if a new user logged in and we showed like the last, like the distinction isn't that important for our purposes. In the demo, Chuck was able to post as Chronic Death using Chronic Death's socket token from the meta tag, but Chuck's script could just as easily enter data directly in the message input, or read Chronic Death's cookie and send it to Chuck, which would allow Chuck to log in directly as Chronic Death. So the actual code I ran is this proof of concept. So I'm able to access ES6 libraries using require instead of the which is an ES5 thing, and sort of how we require libraries now with require.js, instead of using the import, which is the ES6 form of it. This proof of concept also prevents attacks launching back at Chuck by checking the username, and this is important because Chuck could just as easily made this so that it reposted it back into the channel as the exploit again, and it would have become a worm then. Any user input should be treated as untrusted. To safely handle untrusted data, you must escape it, but the rules for escaping data are dependent on where data will be inserted. Is it inside an HTML tag or attribute, and those have different things. Whether it's a script tag, and you have to do JavaScript escaping, whether it's CSS, and CSS you have to worry about because CSS has URL tags, so they could do a remote file read if they can control the URL for a URL lookup for like a background or something. Or is it a URL and you need a URL encode? Just like cryptography, you shouldn't write your own escaping library. Use a trusted library that follows OWASP recommendations. We could escape the message either client-side using JavaScript before appending, or we could escape on the server before broadcasting the message. I prefer escaping on the server because it's less to do on the client, and it prevents the chance of forgetting to escape the message before it's shown to new clients, such as if messages start to be persisted and shown back to users. Decisions on when to escape must be reevaluated when untrusted data is used in a new location. Like if you all of a sudden add support for a native client, their escaping rules might be different, and then it might make more sense to be client-side escaping because you need specific escapes for each client. So all we have to do is use plug.html.html_escape on the message body before broadcasting to prevent the proof of concepts attack. But a similar problem could occur with the username if someone made their username like script alert. And we actually showed usernames to each other, which we do in the chat log. We use plug.html.html_escape instead of phoenix.html_escape because the one from Phoenix returns a tuple of safe because that's how this safe string implementation works inside of Phoenix, and that's meant to be used inside of EEX templates. So if we go through the template system with HTML EEX, we automatically get safe string support. It's just the fact that we're doing direct passing of strings from a user to all the other users that we have to do this manually. And also, if we pass this through the view system, which we could, you can use views from anywhere. It's not just inside a controller. We could get safe stuff if we wanted to send back HTML instead of JSON to the end user. So let's double check our work. Yeah, and so it no longer works. We closed the cross-site scripting vulnerability, but we still need to recover from the compromise by resetting Chuck's account to a state that Chuck doesn't know and banning Chuck's account. Now, realistically, in an actual ban scenario, we would do some different things, and I'll cover those. I'm going to assume we were running the server on a named node so that we can connect with Erlang --remsh or remote shell to run commands to delete Chuck and disconnect his sockets without needing to restart the server. So this isn't just like running Rails console and we have access to the database. This is actually connecting to a live Erlang node. So we're in the memory of the running server. And that's possible because you can just have more processes inside of Erlang. These would also be great things to target with Metasploit. So I'm going to set up some aliases because my example project has a really long name. I don't want to type it over and over again. So we're just going to delete the attacker's account by name, and then we're going to use the socket ID that we set up when we were in user socket to broadcast disconnect on all those ports. And so this disconnect isn't like going through JavaScript and telling the browser to disconnect. It's telling the underlying systems that's maintaining the connection in our server, die now. So you don't have to worry about, oh, well, the user could just not trust the disconnect message and stay connected. That's not the case. If we look in actual developer tools, when this happens, we start getting 500 errors from the server because they no longer can authenticate the user's account. In an actual compromise, you might want to soft delete Chuck, or you might have to do that in general because you have to keep track of all the log messages, that sort of thing. The important part here is Chuck. We want Chuck no longer to be able to log in, so however your system does that. But remember, Chuck's proof of concept exploit grabbed chronic death's socket token, so chronic death needs a new socket token also. Initially, cross-site scripting could have grabbed chronic death's cookie, and he just didn't know about it. So we want to reset chronic death's password too. So chronic death's account will be safe now, right? No, because we just reset his password, not his sessions. If either Chronic Death or Chuck has Chronic Death's cookie, they can just refresh the page after we do this, and they'll get a new socket token inside the meta tag. What were we going to say?
Why is he only the
Oh, they are. Okay. So yeah, then that won't be a problem. No. So the problem is that the API token has to be given to the user somehow in the HTML page, right? And so the problem is if you're already logged in so that you can see the HTML page, which if you have the cookie, that's true, you can keep in the API token off of the HTML. That's the issue we're worried about. So to invalidate sessions, we need to either invalidate a single user session or invalidate all sessions by changing the secret key base. In the event of a real breach, using code like Chuck's posted, which could have hit all users in a given channel, it'd be best to invalidate everyone's session because you might not be able to track down whose credentials were compromised, in which case we would do option number 2. Well, let's say you can prove only a small group of users were affected. How would you go about invalidating one user's or handful of users' sessions using the current authenticate plug? A session is valid if it's not expired, the secret key base matches, and the current user ID can be looked up. We can't change the expiration time or the secret key base for a single user, so we're left with it. We can change, all that we can change is the ID. Well, that doesn't make sense because the user ID is likely a foreign key to other parts of the application. To summarize, we want authentication tokens to be tamper evident, which they are already due to signing, expire, which they do because they include the time, but they must also contain a field that is updatable by the server that can be checked for correctness, allowing for revocation. The user socket token being embedded in the signed socket token metadata allows for it to be revoked, but there is no equivalent field in the session right now. We use this, so to add a session token to the user, we use the same migration as socket token to change the column name to session token. I'm going to have 2 fields for tokens here just so that if there was a breach, we could maybe track that, oh, the session token was used first before the socket token or vice versa, so we know the path of the breach. You could also use 1 token because they're both generated the same way. We then add the field to the user schema. We need to add generating set, but since the tokens are generated the same way, we just refactor and call the function generate token now, and then assign it to a field. And we can interpolate atoms the same way we could do symbols by putting in quotes and putting a colon before it. We had a helper function, put session, that can be used in the controller to set up session keys so the plug can be read from them. Assign current user takes the user session token as an additional argument so that a user session is only valid if both the ID and session token match, which allows us to revoke a session by changing the session token inside the database. We use authenticate.put session in the registration controller and in the session controller. So to recover from the compromise, we need to ensure the authentication tokens are revocable ahead of time, or because Erlang allows us to do hot code loading, we can actually do an update to the server while it's running and do the code patch that I showed without knocking users off until we need them to re-authenticate. We could leave everyone that wasn't compromised running and put in the patch, and it would work. After making sure that we can actually revoke tokens, we need to delete the attacker's account or soft delete it if we need to leave it for forensic evidence for like a criminal case. We need to remove the attacker from the system, which is both making sure that they can't log into HTML and they can't get onto the WebSockets. And we kick them immediately, and we reset the victim account. And this reset must happen atomically. You must set all authentication forms have to be a single database commit. Otherwise, whichever form is open, the attacker could still authenticate to and potentially get the other forms of authentication, which was the case with the session still working after we changed the socket token. And then after everyone's reset, it'll force them to log back in when they try to access anything on the page. So in summary, to protect our secrets, we're going to ignore the secret config files to make sure that the passwords cookies can't be snipped. We're going to use TLS. To protect from CSRF in HTML forms, we just have to use form4 and not write forms by hand, which, benefits. We don't write forms by hand as much. For cross-site scripting in HTML views, the HTML templates already do that for us. But in channels, we have to make a conscious decision about which fields we are going to directly insert into HTML and use plug.con.html escape to do that. Our sessions are revocable because we use a session token inside of them, and we check every time they connect that the session token is still valid. The fact that socket access can't be revoked, we store the token the same way we do for sessions, and because the channel connection is a WebSocket connection, it's persistent, we need some way to kick them off our system if we're not going to have to do a full restart for the update. And so we can do that by giving IDs to our sockets and just sending disconnect to that ID. I got a bunch of help from the Phoenix installation guide itself. The actual help from the mix commands is also helpful. A couple things online about how to use OpenSSL to create certs, because I only know how to do it in Ruby from how Metasploit Pro does it. And then OWASP for making sure I got the definitions right for the vulnerabilities. And RFCs for teaching me that HSTS is not useful on certain ports. Oh, and Michael Etherly's Phoenix app with authentication for the basis of sign up the auth. So nothing like devise, because the difference between devise and auth logic is devise makes templates. So there's nothing like that. And one of the reasons why there isn't is, if I remember correctly, devise was written by Jose Valim, and he doesn't want to write it again. Auth logic, there are some things. There's one called Passport, which I didn't have time to look at, mostly because they would have more code, and I didn't want to have to also teach how to use a specific package for this. And this also demonstrated, like, auth logic has these tokens that are revocable. Like, they have a persistence token and single access token. And this explains why do they have these tokens as opposed to just having the ID in the session, is so that everything is revocable. Because I think it's important that we understand why our authentication works the way it does, even if we end up using another library. Any other questions? Okay.
Luke, you all done?
Yep.
All right.